here a hemispherical shell, right? A hemispherical shell is placed on the xy plane centered at the origin for a vector field is equal to minus y ex cap. See, this ex cap notation is actually I cap. Some book using instead of I cap x cap or instead of I cap ex cap. Okay, don't confuse with it. So I am writing E as, for convenient I am writing this as minus y divided by splitting this denominator y square. This is, we can write this as x cap. I can write as this is x cap, right? Here x y cap divided by x square plus y square. Okay. Now we want to calculate del cross E dot dA, right? So it is better to use in a surface, right? We can represent it using polar coordinate system, because this is x cap y cap, xy plane the function is given. So if I give y is equal to, again you can use, right, y is equal to, you use as, right, because in here dA I am writing dA as, what is dA, right, in the xy plane what is area, that is dx dy, right, z cap, right. Alright. Now I can convert, right, x cap y cap. Now this y is equal to, suppose I am giving r sin theta, right. Alright. So this is a del cross E dot dA, right. So integral del cross E dot dA using Stokes theorem you can write as integral E dot dl, surface integral converted into line integral. That is very easy, right. So I can write this as dx x cap plus dy y cap, length element, alright, length element I am applying, alright. Now put x is equal to r cos theta, see, x is equal to r cos theta, y is equal to r sin theta, dy is equal to r cos theta and r cos theta d theta, and dx is equal to r into cos theta changing minus sin theta d theta, right. Now substitute here, integral minus, what is y, r cos theta, what is x square plus y square, that is r square into cos square theta plus sin square theta. So I can write r square. Now what is dy, right, this one here dx come, y dx, x cap dot x cap 1, here dx come. So dx value minus r sin theta d theta, minus r sin theta d theta, alright, plus again x is equal to what, r cos theta, x square plus y square, again r square, right. Now this dy is r cos theta, right, dy is equal to r cos theta d theta, alright. So because here x dy come, y cap dot to y cap 1, so minus dy is r cos theta d theta, right, r x is equal to r cos theta and y dy is equal to, x is equal to r cos theta, then here dy is the component, here I applied dx, alright, here I applied y I changed, right, y is equal to, I am sorry, y is equal to r sin theta. Y is equal to r sin theta. Already we have a negative sign here, right? Don't confuse. R cos theta, then dy is r cos theta d theta, right? R cos theta d theta. Alright. Now, hemispherical surface. Look here. Over a hemispherical surface, see, suppose for a hemisphere you consider, right? Here 0, here only pi come, right? So, integral 0 to pi is the limit, alright? Alright. Now, this I can write as integral 0 to pi, see here r square, then sin square theta plus cos square theta only remaining, right? D theta, right? Now, sin square theta plus cos square theta is 1, right? So, d theta on integration theta. Theta 0 to pi, what is the answer? Pi. Pi is 3.14. So, 3.14. Alright.